Okay, so I want to show you how to use implicit Euler method to solve differential equation numerically. So the implicit Euler method is also called the improved Euler method. So we're looking at this question using improved Euler method, which is the same thing as implicit Euler method, solve numerically this differential equation, and this is the initial value condition. So we are asked to get for x equals to 0.2 and x is equals to 0.4. So what does that simply mean? It means that the step length h is 0.2. Now the formula for the implicit Euler method or the improved Euler method is this. Now the red indication here shows that it is explicit. So this is the explicit Euler method, yn plus 1, which is used like a predictor corrector method. So we use this Euler method to predict, then we use the implicit method to correct. How do you really be able to which one is implicit or explicit? Now let's look at the explicit. Now looking at yn plus 1, you will not find any of these yn as yn plus 1. That is when we say it is explicit. But look at the implicit. You have yn plus 1 here. You also have yn plus 1 here, showing that this is a predictor corrector method. So this is an implicit Euler method because this has yn plus 1. You also have yn plus 1. Unlike the Euler, you just yn plus 1. You don't have yn plus 1 here. So that this is an explicit Euler scheme. So now, if you now want to write this one by simply substituting the red, which is the explicit, back into this one. So you have the implicit, implicit Euler method becomes yn plus 1 equals to yn h over 2 f of xn yn plus f of xn plus 1 comma yn plus h f xn yn. So what I've just done is I substituted the value of or the Euler explicit back into the implicit to have this. You can as well use this one. Just first find yn plus 1, put it in that, then you compute it and have this like that. So now how do we solve this one? So solving this one this is what we're going to do basically. So our y prime is actually y plus exponential x. So what does that suggest? Now for y 0 y0 equals to 0, this simply means that x naught is equals to 0, y naught is equals to 0. So x1 definitely is going to be 0.2, x2 is going to be 0.4. So here we can see our step length is 0.2. It is moving at 0.2 because from 0 to 0.2 to 0.4. That means the step length is at 0.2. So now we have the implicit scheme. So we can then write it. This is what we have, okay? So when n is equal to 0, so we have this here. This is going to be y1 equal to y naught plus h over 2 f of x naught y naught plus f of x 1 comma y naught plus h x naught y naught. Then we have bracket close. Okay, so now we just simply substitute all these values here. So we have that. So now our y naught is actually 0. We already know that. Okay, So plus h is 0.2. We already have that here divided by 2. Now this is f x naught y naught, of course, and that is this. Okay, so we simply substitute. So this becomes y naught plus ex naught from this. That's what that is. Okay, plus now the whole of this. Actually, this is going to be x1. So this will be y naught plus h y naught plus exponential x naught, because that's for this. Okay, plus exponential x1. Okay, exponential x1. So because this f of x naught is this. Okay, now the whole of this is going to be, this is the implicit, this one, so it's the explicit. Okay, then plus x naught, x1, which is this one. Just simply substitute x as x1 here. So this one is this, and that is that. So now, having said that, now we simply then can put the value of that here. Of course, if I divide this by this, I'll get 0.1. Now y naught, of course, is 0, and e raised to power 0, of course, x naught is 0, so that's going to give us 1. Y naught is 0 plus our h is 0.2. Then we have y naught is 0 plus e raised to power 0, because x naught is 0, that's 1, plus e raised to power 0.2, because x1 is 0.2. So if we put this one in our calculator, so our y1, put all of this in our calculator, solve it, then you get 0.24214. So what does that mean? It means that our y at x is equal to 0.2 is 0.24214. Okay. Now the next one is, we now say for when n is equals to 1. So we go back to the equation when n is equals to 1. So this becomes y2 and the likes. So we can have this one as y2 is equals to y1 plus h over 2. Then we have this as f of 1, y1 plus f of x1, comma, y1 plus h f of x1, y1. So that's what we have. Okay. And I think there's another bracket. Yes. So already we have y1, is the one we just calculated. So now we can just simply substitute that into that. And before we do that, let's do something here, because f of x1, y1 is actually y1 plus x1, which is going to give us 0.2. Our y1 was what we got the last 24214. Okay, plus exponential 0.2. Okay, so if we do this, we should get 1.46354. And similarly, y1 plus hf x1 y1, this as well is going to give us of course our y1 is 0.24214 plus 0.2, that's our h. Then this, we already have this, which is this, that will be, we've already calculated this one, f of x1 y1, which is this, that will be 1.46354. So if we add all of this, multiply this and add this to, we should have 0.53485 from my calculator. So now what we need to do now is simply substitute all of that into the equation. So now we have this one as our f of. So we have this one, right? And this one. We already have this one. We already have this one. So now let's get the whole of this one. So we then can add this one together. So our f of x1, comma y1 plus h f of x1 y1, okay, is going to give us our f of, now our x, this should be x2, sorry, this should be x2, this should be x2 because it is n plus 1, yeah, from the formula is n, because n is going to be what's it called, n is going to be 1, that will be x2. So this will be x2, not x1. So our x2 actually is going to be 0.4, this, what we calculated the last time, is actually 0.53485. Okay, so calculating this is going to give us, this is like our x from the f of x, something like this. So this is going to give us our y 0.53485 plus 0.4. Okay, so if you add these two, we get 2.02667. Okay, so now our y2, this is actually 0.4, is going to be this is this, okay, 0.24 from the formula, because this is, we're just simply substituting all of this here back. This is this, then we have this one, we have this, then we now write everything back to just like substituting into this equation. Okay, that will give us 0.2214 plus 0.2 divided by 2. Already we have this one as this one, yeah, this one, this is this one, and from the formula, this is actually has been calculated to be this. That's going to give us 1.46 1.46354 plus the last one, 2.02667. So now calculating all of this together using your calculator, just like I have done, so this is going to give me 0.59116. So therefore our y of 0.4 is 0.59116. So now that's how to use implicit to numerically solve a differential equation of this kind. So what did we do? This is quite what we're going to do for implicit and explicit method. So I hope you find the video interesting. If you do, kindly subscribe and share. Thank you.